Hi. The periodic classification of elements was a kind of historical chapter. We just studied which all scientists did, which all categories of classification on the elements that were known at that time. So that was an entertaining chapter. Now let's look on few questions. Short answer type 2 marks. State Mendeleev's periodic law. Write 2 achievements of Mendeleev's periodic table. As you all know, the Mendeleev's periodic law is properties of elements are the periodic function of the atomic masses. According to this law, Mendeleev arranged elements on their increasing number of atomic masses. The achievements are, it could classify all the elements discovered at his time. It helped in the discovery of new elements. It helped in correction of atomic mass of some of the elements which were incorrect during at that time. Next, how can the valency of an element be determined if its electronic configuration is known? What will be the valency of an element of atomic number 9? If the element has 1, 2, 3 or 4 valence electrons, its valency will be 1, 2, 3 and 4 itself respectively. Similarly, if the element has 5, 6, 7, 8 valence electrons, its valency will be 3, 2, 1 and 0. Which means, let's take an example. In the case of nitrogen, nitrogen has 5 valence electrons. It needs 3 more electrons to fulfill the noble gas configuration. So, its valency is 3. Element with the atomic number has electronic configuration 2, 7. 2 in the first shell, 7 in the second shell. So, its valency will be 1. Because this element needs 1 more electron to complete the noble gas configuration. Next question, how does valency of elements vary while going down a group and while going from left to right in a periodic table? While going down a group, the number of shells increases, but number of valence electrons remains the same. So, while going down a group, the valency of the elements are same in the same group. While going across a period from left to right, 1 electron is added. So from extreme left, if the number of elements is increasing, if you write from left to right, the valency increases to 4 first, then decreases to 0. So this is the case how it goes from left to right. Short answer type question 3 marks. How many periods are there in the modern periodic table of elements? How do atomic radius, valency and metallic character vary down a group? How do the same vary down from left to right in a period? So let's answer one by one. There are 7 periods in the modern periodic table of elements. Down a group, atomic radius increases because down a group, number of shells increases, which increases the distance between the valence electron and the nucleus. Down a group, valency remains the same. Down a group, metallic character increases because since the distance increases, an element could possibly lose the outermost valence electron very easily, making it an electropositive element. So, as down the group, the electron positivity or the metallic character of the particular element increases. Across a period, atomic size or atomic radius decreases. This is because the shell size is not changing. The number of shells is same. 1 by 1 electron is added 1 by 1 on the elements. So this means that on adding each electron, the atoms shrink due to the effective nuclear charge of attraction between the nucleus and the electron. So the atomic radius decreases. The valency increases 1 by 1 till 4, then it is decreasing to 3, 2, 1 and 0 till noble gas. The metallic character decreases across a period. This is because as we move across a period from left to right, the non-metal area is reaching where the element could not lose the electron so easily, so it gives electronegative character to the element. So across a period, metallic character decreases. Next, what are the merits and demerits of Newland's classification? As we have studied, Newland's classification is called law of octaves. It showed that every 8 element showed a property similar to the first element. The merit was its classification worked well for lighter elements, but only up to calcium. It gave a relation between the properties of element and their atomic masses. By his classification, it was shown for the first time there exists a periodicity in the property of elements, which means a recurrence. These three was the main merits of Newland's law of octaves. Demerits was this classification failed when heavier elements beyond calcium came into action. It could not obey to the Newland's law. At the time of his law, noble gases were unknown. When noble gases were discovered, neon, which is between fluorine and sodium, and argon between chlorine and calcium, it became the 9th element and not the 8th element, which had similar properties. The 8th element didn't have any similarity to the noble gases. So this law was broken. This was a major demerit. Next question. Two elements X and Y belong to group 1 and 2 respectively in the same period of a periodic table. Compare them with respect to periodic table from left to right and Y. The number of valence electrons in their atoms, their valencies, metallic character, sizes of their atom, formula of their oxide, formula of their chloride. So these things are the main strategies we need to look the aspect. So first one, the number of valence electrons in the atom. As the question says, X and Y belongs to group 1 and 2. The group 1 elements has 1 valence electron and group 2 elements has 2 valence electrons. So X has 1 valence electron and Y has 2 valence electron. Next one, valency. From the group itself, valency of X is 1, valency of Y is 2. Metallic character. X is more metallic than Y because Y is coming after X. Across a period, left to right, metallic character decreases. So X is more metallic character than Y. The sizes of the atom. X is bigger than Y. This is also the same reason. From left to right, atomic size decreases. X is coming first, so X is bigger in size. Formula of the oxide. Valency of X is 1, so the oxide formula is H2O. Valency of Y is 2, so the oxide formula is YO. Formula of the chlorides. Valency of H is 1, so the chloride formula is HCl. Valency of Y is 2, so the formula is YCl2. Long answer type 5 marks question. This is a really big question. Let's read it. Atoms of the 8 elements A, B, C, D, E, F, G and H have the same number of electronic shells but different number of electrons in the outermost shell. It was found that element A and G combine to form an ionic compound which can also be extracted from seawater. Oxides of the elements A and B are basic in nature while those of E and F are acidic in nature. Oxide of element B is almost neutral. Answer the following questions based on this information. To which group or period of the periodic table do the listed elements belong? Which one of the elements is likely to be a noble gas? Which one have the largest atomic radius? Which one is likely to be a non-metal? Which one is a metal, a semi-metal or metalloid? So, let's analyze this question. A, B, C, D, E, F, G and H are the 8 listed elements. It is already given that the element A and G forms an ionic compound which can also be extracted from seawater. So it is evident that the compound Ag is nothing but NaCl sodium chloride. So the element A is Na sodium and the element G is chlorine. The period to which this list belongs is the third period. A and B belong to the first and second group. H is the noble gas group, C is the 13th group, D is the 14th group, E is the 15th group, F is the 16th group, G and the 17th group. So this is the group details. Coming again to the question details, it is already given that oxides of elements A and B are basic in nature. This makes the group clarity, which means A and B are first group elements. The elements of first and second group have their oxides acidic in nature. Similarly, the oxides of E and F are acidic in nature. This also makes group clarity. The E and F oxides are acidic in nature. These oxides are formed by nonmetals. The next question, which is a noble gas? H belongs to a noble gas. The largest atomic radius is A. Nonmetals are E and F. A semi-metal or a metalloid is D. Next question, did Mendeleev have gaps in the periodic table? Say 3 limitations of Mendeleev's classification. Does electronic configuration of atoms change in a period with increase in atomic number? So the first question's answer, yes, gaps were left for undiscovered elements in Mendeleev's periodic table. We all studied that. A prefix like Aka was given to each element to possess or to give space to the undiscovered elements like Aka boron, Aka silicon, Aka germanium, etc. Second question, 3 limitation to Mendeleev's classification. Major limitation, position of hydrogen was not justified. Second limitation, increasing order of atomic mass could not be maintained everywhere. It was deviating. Third limitations, isotopes having similar chemical properties from different atomic masses, they could not be separately placed, which means there was no efficient space or no liable space for isotopes to be given or accommodated in the Mendeleev's periodic table. Last question, does electronic configuration of atoms change in a period with increase in atomic number? Number of shells remains the same. Number of valence electron goes on increasing from left to right in a period till the octet is complete.